Good afternoon or good morning for some of us. This is Ellen Jonkere. I'm the CEO of HRD Antwerp. On behalf of HRD Antwerp, I would like to personally welcome you for the first edition of our HRD Talks. As the world moves towards new technologies, the importance of research and development plays a crucial role in the growth of an organization. Without research, we would not know what to expect at different levels in our industry. In this first edition of HRD Talks, our research scientist, Ekaterina, will present a few case studies on the latest developments in lab-grown diamonds. The case study findings are a joint effort by our in-house research scientists, Mrs. Marleen Boeman and Mrs. Ekaterina Kovalenok. Thank you once again for joining us. I now hand over the session to Ekaterina. Thank you for joining us.
Bye-bye. Thank you, Ellen, for your encouragement and support. We really appreciate it. My name is Ekaterina Kovalenok. I'm a research scientist in HRD Antwerp. In the past, I studied geology and geochemistry in Novosibirsk State University in Russia. And also, I did some research in the laboratory of experimental mineralogy and crystal genesis in the Institute of Geology and Mineralogy in Novosibirsk. I'm very happy to be today a part of our first HRD presentation. And I also would like to thank my colleague, another research scientist, Marleen Bouwman, for significant parts of research work that we had in recent years. And also, I really would like to thank my colleague, Vicha Majumdar, for this fantastic possibility to organize this event today. And I hope in future, many other HRD talks. I hope everyone can see my presentation. Today, we're gonna talk about the latest in lab-grown diamond developments. And first, I would like to introduce you exactly what kind of services our company provides. We provide different certification services on loose diamonds and diamond jewelry, but also our company is well known for its higher quality, multidisciplinary educational programs for all jewelry professionals, retailers, and just anyone who is interested in gemmology. In our laboratory and specifically in our research department, we use very sophisticated equipment. And the methods that we used in research are infrared spectroscopy, optical absorption spectroscopy in ultraviolet visible region and near infrared region, also diamond view imaging, and of course, photoluminescence laser spectroscopy. For such service as MELI screening, we use different kind of techniques, and one of them is UV photoluminescence laser spectroscopy. And today, I would like to introduce you some research cases that we had in recent years. These cases, the names of these cases you can see now on my screen. But before we start, I just would like to remind everyone that the lab-grown diamond is still a diamond. The only difference is that it's produced in the laboratory and not created by natural geological processes. There are two kind of techniques that heard already existing. It's higher pressure, higher temperature technology and chemical vapor deposition technology. The conception between these two different techniques for diamond growth is different. For HPHT diamonds, they use a temperature gradient method at higher pressure, higher temperature parameters. And for CVD technology, they use the gas phase, which is a carbon rich, and they grow diamonds on a substrate from this carbon-rich gas phase. The parameters for pressure are lower as well as for temperature. These types of lab-grown diamonds, HPHT and CVD, they also have different types of morphology. I would like to show you some samples that we have in our collection. So this is a rough HPHT diamond of the size it has a weight 1.24 carats, and you can already observe, I hope, this cube octahedron morphology. Lab-grown diamonds, they also can exist in different colors. So now I showed you an example of a colorless HPHT diamond, but we also have some samples of blue HPHT diamonds, as you can see here. That's a very small one of 0.35 carats. And another one, the yellow, with a weight 0.51 carats. For all the crystals, you could see this typical cube octahedron morphology. The CVD diamonds are grown as diamond plates, and I will show you one small sample of a CVD rough diamond that we have with a carat weight of 0.35 carats. You can see it has a little bit of yellowish brownish tint. Also, this kind of rough diamonds, rough lab-grown diamonds, they can be post-treated, so they can be treated afterwards to improve the color or to change the color. Also, as an example, I would like to show you some polished lab-grown stones that we have. For instance, the fantastic fancy vivid orangey yellow one, and fancy deep blue. So these two stones are also HPHT diamonds, but polished. The most difficult part is to identify between the polished diamonds, whether they are natural or lab-grown. And now I want to show you some examples of polished colorless stones that we have. One of them is a CVD diamond, and another one is natural. I will not tell you now which one exactly is a CVD, but this is one of them. They are both approximately the same size. And this is another one. As you can see, visually, or also using a magnification, it's not possible to say whether these stones are natural diamonds or lab-growns. So the first stone that I showed you was a CVD diamond, and the second one was a natural diamond. So this is exactly why we really need to do a lot of research work to be always updated, to be able to make a difference between lab-growns and natural stones, as well as to identify different kind of treatments, both for lab-growns and natural stones. All diamonds, both natural and lab-growns, they can be classified within the type classification system. This system is based on the presence or absence of nitrogen impurities in diamonds. Most of the lab-grown stones can be referred to the type 2 category, or the category without nitrogen impurities. Also, some parts can be type 1b stones with isolated nitrogen atoms, but also some lab-growns can have some amount of A centers, and quite often they can be also mixed type between 1b, 1a with A centers, and also another interesting mixed type is 1b and 2b. So that means that those diamonds contain both nitrogen and boron impurities. And now I would like to introduce you some particular research studies that we have done in recent few years. And our first study, our first research work was about CVD diamonds in color range from D to Z. We received in our laboratory around 2,000 samples, which were disclosed CVD diamonds, and all of them were from different clients. One client provided us samples which were also treated after they have been grown, and another client provided us CVD diamonds which have not been treated afterwards. The last client, client C, provided us the mixture of both two types of CVDs. So we wanted to know what can be the difference between them, and also what is the difference in quality for those stones according to 4 Cs. In general, these stones had following 4 Cs characteristics. You can see them on the screen. Analysis shows that the stones which were just grown and not treated, they had a better color. As you can see, more or less that top color from D to F. The stones which have been treated they fell into color range between G to J. But as you can see already on this diagram, the color was not that good as for S-grown CVDs. The analysis of clarity grade showed that in general, all the samples, they could be referred to the between categories of VVS1 and SI2. Also, we had some PK stones, but the average was between VVS2 and SI2, which is actually quite good. And also, what is interesting that again, the stones that have not been treated had a little bit higher clarity grades, as you can see also from this diagram. The overall weight of the stones was between 1 and 1.50 carats. However, the stones that have not been treated, the size of those stones could reach the weight up to 3 carats or 3.5 carats. So the stones that have been treated, they had lower carat weight category than CVDs which were S-grown. Most of the stones had a round brilliant cut. The results of diamond view imaging confirmed that these diamonds were CVD diamonds. We took pictures from the pavilion and from the crown. And as you can see now on these fantastic photographs, they revealed very typical for CVD diamonds multi-layered structure that I show you now on the screen. This kind of structure reveals the growth features. Normally, you can observe it both from the crown as here. You can see these lines also, as I showed from the pavilion, can have a little bit different orientation. So those were the stones which have been treated. And now I will show you the results of diamond view imaging for the diamonds that were S-grown, so they haven't been treated. Here on these pictures, you again can observe this fantastic multi-layered structure. So you can see these thin lines from the pavilion in this case. Also here, you can see these lines. But some of those CVDs, they also displayed a very interesting fluorescence pattern that is quite typical for so-called new generation CVDs. And what is that? One of the examples you can see here. So you can see this CVD diamond that has actually the blue color of fluorescence, which is more typical for natural diamonds. It also can have a little bit of irregular fluorescence pattern, which is also typical for naturals. However, it's quite different, so you always can make the difference. Another example, you can see, I'll show you some pictures of mixed types of diamonds, both treated and non-treated, as you can see here. So this is the picture from the crown. Again, here you can see this fluorescence pattern, quite typical for new generation CVDs. And again, from the pavilion side, you can observe, maybe not that clearly on the small pictures, but the multi-layered structure. The results of infrared spectroscopy showed us that these CVDs, they were type 2A. However, the stones which have been treated also displayed the presence of C centers, as you can see from this fantastic absorption line. At the end of our research work, we made the conclusion that the CVD diamonds that have been treated afterwards, that have been HPHT treated, they reveal lower quality of stones. The average size of these stones was around 1.10 carats, and they had typical spectroscopical and diamond view imaging features that you also can see on my screen. The stones which have not been treated, they revealed higher quality in comparison to other CVDs. The overall size of those stones were also bigger. So the average size of this type of diamonds was 1.70 carats, and they had different fluorescence pattern a little bit, and also different color. Another research study, which is actually currently still in progress, is our study, again, on CVD diamonds, but in a pink color. We received and we studied around 155 disclosed CVD diamonds. Their characteristics, according to 4 Cs, now you can see on the screen, but in general, they had fancy pink or fancy purple color with different hues. And also, as you can see here, the size of the stone was not that large. So they were all less than 0.40 carats. This is a selection of some pink CVDs that we received. Here you can see the actual photos of those stones with different examples of color that they had. They were all round brilliance. The analysis on their color showed us that most of the stones they had a fancy vivid pinkish purple color, or fancy intense purplish pink color, or fancy vivid purplish pink color. And the clarity grades of these pink CVDs was also in average quite not bad. So you can see the majority of them fell into the clarity category between VS1, VS2, SI1, SI2, but there were still quite many stones that had a very good clarity grade, as you can see here, VVS1 and VVS2. And even there was one stone that was a loop clean. The results of optical absorption spectroscopy in UV visible and near infrared region showed us that these pink CVDs, they certainly had signs of irradiation that you can see here by these absorption peaks. And also they displayed the presence of NV centers that you can see here by these 2 absorption lines. Quite typical was the presence of silicon vacancy, which is always present in CVD diamonds. The results of this of infrared spectroscopy showed us that these stones had C centers, so they had some isolated nitrogen impurities, but they also had some very typical absorption lines, typical for pink CVDs, absorption lines that you can see here, which are related to nitrogen and hydrogen complexes. The results of diamond view imaging again confirmed us that these stones were CVD diamonds, and you can observe one more time this fantastic multi-layered structure from the pavilion and from the crown. In general, we made some conclusions that we noticed that the size of these pink CVDs were quite smaller in comparison to just CVDs from the color range D to Z. Also, most likely, the color of the stones, the pink color, was caused by irradiation and annealing treatment. And also typical spectroscopical features you can see also on this slide. As I mentioned before, the NV complexes, the signs of irradiation, and the silicon vacancy. Apart from research work on CVD stones, we also do some research on HPHT diamonds. And I would like to show you some research work that we did for yellow HPHT lab bronze. We selected some yellow HPHT diamonds. They had following characteristics according to 4 Cs. Here, actually, you can see the actual photos of these samples now. They all had a fancy, intense yellow color. The microscopic analysis showed us the presence of many dark inclusions that are actually the remnants of the metal solvents that they used during the HPHT growth process. Sometimes these kind of inclusions, they also can be that large that you can even see that with the naked eye. Iron-containing inclusions which can be present in HPHT diamonds sometimes also can display magnetism. However, of course, it's for the practical use, it's not reliable methods how you can check whether your diamond is lab-grown or natural. So that's why we highly recommend always to try to do the sophisticated analysis of this type of diamonds. So basically, it's quite important to make the research in the laboratory. The optical absorption spectroscopy results, again in UV visible and near infrared region, showed us that all of the stones, all of the diamonds, they had quite typical one sort of 1B spectrum. And what is quite interesting, the results of infrared spectroscopy showed us the presence of both C centers, which are isolated nitrogen impurities, and also presence of boron that you can see by this absorption band. Also here we have C centers, and we also have a positively charged substitutional nitrogen indicators. And also on this slide, you can see very typical absorption line for boron. The results of diamond view imaging confirm that these these diamonds are HPHT. However, in this case, you can see the different fluorescence pattern, different in comparison to CVD diamonds. This can be observed by these interesting cross sectors, especially visible from the pavilion in this case. Again, this kind of fluorescence pattern show the growth features. As you might heard, the CVD growth, they deposit the carbon atoms layer by layer. And for HPHT, they use a different conception. For HPHT stones, the growth is carried out on a cuboctahedron diamond seed from a solid carbon phase by presets of metal solvents. Also, these samples, they revealed some signs of phosphorescence. So they had from weak to strong phosphorescence. And they had, we detected by energy dispersion X-ray fluorescence method the presence of some metals as cobalt, iron, copper, and platinum. In general, in our laboratory, we receive quite large amount of yellow HPHT lab growns. Intense yellow color is quite common, but as well as, for instance, fancy vivid yellow color, they can be in different shapes as brilliant, but also fancy. And the average size of these HPHT diamonds exceed 1.50 carats. The typical spectroscopical features that we also discovered, you can see here. I didn't really show you the results from photoluminescence laser spectroscopy analysis, but you also can see that we found the presence of some nickel-related defects, which is quite also typical for HPHT diamonds. And the last case for today that I would like to share with you. Once in the laboratory, we received the so-called hybrid diamonds, which was actually the overgrowth of CVD diamond on a natural diamonds. This technology exists already for many years. However, it's not that common to receive quite large stones. And in our laboratory, we received a diamond of 0.75 carats that had a fancy grayish blue color and a princess color, as you can see from this picture from the crown and pavilion. However, when we started doing our investigations, in the of optical absorption spectroscopy in UVVs, we found out that diamond had a typical absorption areas, which are responsible for the presence of different nitrogen aggregates, as you can see here. And also, but at the same time, what was quite special, it had a boron absorption continuum. So it also had an absorption in this area, which is quite more typical for blue diamonds. Results of infrared spectroscopy showed us that, again, this stone had a nitrogen complex and at the same time boron-related absorption. And finally, the results of diamond view imaging showed us that from the crown, this stone had a very typical CVD fluorescence pattern, as you already saw in other examples that I showed. However, from the pavilion sides, this stone had a typical natural fluorescence pattern, as you can see here, very typical blue fluorescence color, and also some natural growth features. And from the profile, we also tried to take some pictures, and we saw that actually, on the top there was a CVD diamond, and on the bottom or in the pavilion there was a natural diamond. This stone resembles some phosphorescence. The results of our investigations showed that the blue color of the stone was caused by the boron reached CVD layer. So there was a CVD type 2B diamond overgrowth on a natural stone. We were quite surprised by the large size of this diamond, 0.75, because it's not that easy to create a very thick overgrowth on a diamond. Even these types of the stones, these so-called hybrid diamonds, they are not that abundant on the market. However, we always need to be aware of this kind of diamonds. Also, sometimes these hybrid diamonds as a crystal core, they can have not just a natural diamond, but they also can have some imitations, as for instance, cubic zirconia. So it's quite important to do a very sophisticated analysis with a sophisticated equipment for these kind of stones, and especially for fancy colored diamonds. And we already at the end of our meeting today. I would like to share with you final results on our research in general. What we detected the certain increase of quality in CVD productions. As you already might seen in the first case study that I showed you, that some CVDs, they can be quite large in size, they can have very good clarity characteristics as well as a top color. So average size of these stones is around 1.70 carats. Quite interesting that nowadays, when Argyle mine, the main source of pink diamonds, closed last year, and in general, pink diamonds, pink natural diamonds, they are quite rare. Pink Lebrons, and especially pink CVDs, they can be a good alternative for to replace this kind of so now they become more present on the market. Also, the analysis of this pink CVDs showed that the color of the stones, it was caused by also different treatment techniques as irradiation and annealing. Pink diamonds, pink CVDs, they can be in a different color. They can have different colors of pink or purple, also with a different kind of hues. However, it's also interesting that fancy pink colored CVDs actually are less in size. They are smaller in size than CVDs in color range from D to Z, which are now present on the market. And one of our research on HPHT diamonds showed that as a yellow HPHTs, we can have sometimes very interesting type of the diamond type as mixed 1B, 2B, which is quite interesting phenomena that and it requires further investigation, because this kind of diamonds, which have both nitrogen and boron impurities, are not that easy to have in quite large sizes. And the stones that we studied in our laboratory had an overall size around 1.50 carats as well. And let's don't forget about another material existing on the market. It's also always possible to have these type of stones as a hybrid diamonds. And the presence of this kind of stones on the market just show that the CVD technology is constantly improving. So we always need to be updated. That's why in our laboratory, we try to do as much research work as possible to be able to follow all the last trends for lab-grown diamonds and also color-treated diamonds. And I would like to thank you for your attention.